Hello guys, hi everybody, how are you doing? How have you been doing for the last 2 months? Actually, I was not making any video and I was not posting any video in the YouTube because for the last 2 months I had been doing my private project, that was my graduation project, that was called thesis. For that matter, I gave up posting the videos that I used to post in the YouTube. I'm so sorry for that. Now I came up with a new topic and with very important task for you. What I need from you is just follow my videos, just subscribe my videos, like, share. So that's your task to do for me. So now, as I told you before, I came up with a slab that is called solid slab type. What I'm going to show you is today now um, the number of bars or reinforcements which are needed for this panel. I'm going to show you that one. Okay, so just follow me up carefully and focusedly here. Before doing anything here, we do have things to assume first. So the first one to assume is the diameter. We should assume the diameter that we're going to use for our calculation. Okay, so entering into the symbol and then inserting the diameter symbol, and then okay, so the diameter that I want to assume is 12 millimeter. It's sufficient. So here another thing that you should assume is the spacing one. So the spacing that I'm going to use for my work or for my task is 20 centimeters. So most of the time in design calculation, the dimension or the spacing used is 20 centimeters, so that's why I used here. So nextly, what we will do is here, since our purpose is calculating the number of bars or reinforcements which are needed for this panel. So firstly, I just have to do something. That is I have to calculate the reinforcements in the shorter direction, that is called the main bar, and also the reinforcement the longer direction. So as to calculate, or so as to do that, I can start from here calculating the main bar, or the reinforcements, or the amount or the number of bars in the shorter direction. It's called the main bar. Okay, so as to do that, the formula I'm going to use for calculating the main bar is using the longer dimension and dividing it by the spacing one. So the dimension of the longer direction or the longer length is 5 meter. That's gonna be divided by the spacing, that is 0.2 meter, and we're gonna have to add one for the safety. Okay, so one can be added here. Then we can calculate it. 5 divided by 0.2, how much? We can calculate it using calculator. Okay, so here we do have the calculator application. So using the calculator application, we can do our task. So 5 divided by 0.2 sorry, 0.2, then it's going to be 25. So uh, 25 plus 1, 26. So here we do have 26 bars in the shorter direction. That's called the main bar. Now we should calculate the reinforcement, the amount of reinforcement or bars in the longer direction. So so as to calculate that, now secondary bars. So to calculate the number of bars in the longer direction or the secondary bars, we can use the formula, the shorter length divided by the spacing is gives us the secondary bars, the amount of reinforcement in the longer direction. So the shorter length or the shorter dimension is 4 meter. That's gonna be divided by the spacing one. So the dimension of the spacing is 20 centimeter. That is going to be 0.2 meters. So using that again, adding one for safety. So adding one for safety, we do have here how much? So here 4 divided by 0.2, how much? 20. So adding 1, 20 plus 1, how much? 21 bars. So we do have 21 bars in the longer direction. So we already have calculated the amount of reinforcement or the number of bars in the main and also in the secondary direction. So after having finished that one, the next thing that we're going to do is, we're gonna have to multiply the number of bars with its own length. So in another way, what I'm saying is, just finding the total bars in the shorter as well as in the longer direction is the next task to be done. So in order to calculate the total number of bars or the total length of bars in the shorter direction, what we will do is, multiplying the number of bars with its own length. So total main bar is equal to 26 times its own length is how much? 4 meter. So 4 meter. So we're gonna have the total length. So what you're doing is, finding or calculating the total length of the main bar. So that be here we can calculate using calculator. Okay, so 26 times how much? 4 meter, 104 meter. So the total length of the main bar is 104 meter. So the next task to be done is finding or calculating the total length in the total length of the secondary reinforcement. So total secondary reinforcement is equal to multiplying the number of bars in the longer direction with its own length. Okay, so how longer direction, the number of bars in the longer direction is 21 bars multiplied by its own length. The length of the longer direction is 5 meter. So it's going to be how much? 21 multiplied by 5 meter, 105 meter. So it's going to be 105 meter. So after having finished this one, finally we're going to do, our main target here is finding the total weight of the reinforcement, which are needed for this panel. So as to do that, we have already calculated the total length in the main direction as well as also in the secondary direction. So the other task to do is using this one. First here we have to calculate the unit weight of the bar or the reinforcement. So we have the formula for doing that one. So here, using the symbol here, unit weight, this one, insert, and then the formula is going to be 0.222 multiplied by diameter squared. So we can use here d squared. Square d, and then divided by 36. Then using this formula we can calculate the unit weight of a bar. So 0.22. So the diameter we assumed is 12 millimeters. So using that one we can calculate the unit weight of a bar. So 0.22 times 12 squared and divided by 6. So how much we can calculate? 12 squared, it means 144 times 0.222 divided by 36. 0.888 kg per meter. 0.888 kg per meter. So in 1 meter we do have 0.88 kg of a bar we do have. So using this one, next thing what you'll do is it's so simple. The amount of reinforcement in the main direction is going to be multiplying the unit weight of a bar with its own total length. Okay, so here coming up here TMB in kg is going to be how much? Multiplying the total length, its own total length with the unit weight. So 104 times the unit length of a bar is 0.88 kilogram per meter. So how much we have here? Times 104 meter. How much? 92.352. So here we do have 92.352 kg. And then nextly we'll be calculating the mass of the secondary bars. So that's going to be done in such a way that we have done for the main bar. So it's going to be is equal to 105 times 0.888. How much? We can calculate 0.888 multiplied by 105, 93.24, 93.24 kg. So here we have already calculated the amount of reinforcement in the main as well as also in the secondary direction in kg. So what we'll be doing next is adding those two amount of bars together. So then finally we can put as an answer. So then after that we can confirm or we can assure that we have found the total amount of reinforcement which are needed for this solid slab type or for this kind of panel. So as I told you before, what we'll be doing next is those two together. So it's going to be 92.352 plus 93.24. So it's going to be plus 92.352. So 185.592 is the final answer. So how much? 185.592 kg is the final answer here. So we've done our task here, so we can stop here. Thanks for watching this video. Thanks for following me. In another section or in another class I will come up with another new topic. So for today I have a great respect for you. Bye bye, see you in another section.